moving on. Do a few more weight volume percent and then we'll do some molarity practice problems. So next question says, how many grams of sodium chloride are needed to make 0.25 liters of a 1.5% weight per volume saline solution? So a saline solution is just a salt solution. So here we're given the volume, we're given the denominator part, we're going to put that there when we convert it to milliliters. We're given the percent, we don't have grams. That's what we're solving for in this equation. Okay? So we'll plug things in and we'll solve what we have. And we'll plug in what we have and then we'll solve for grams. But we first need to convert liters to milliliters. So let's do that first. 0.25 liters times, okay, so for every 1 liter we get 1,000 milliliters. So that should be 250 milliliters. Alright, now that we have the correct units for volume, we'll plug our percent in. 1.5% equals, we don't know how many grams, so we'll put an X here, X amount of grams of solute. And then we'll plug in, we have 250 milliliters of solution on the bottom. Don't forget the times 100. So if we're going to solve for grams, we need to divide both sides of the equation by 100. When we do that, the percent goes away, and what we're left with is 0.015. Okay, and now that's a decimal, not a percent. And, oh, Siri, not now, sorry. Okay, so that equals grams over 250 milliliters. So now we're going to cross multiply. Sorry, that's a little crammed together, but this cancels out on this side. And now we can just do 250 times 0.015 equals, I'm going to report our final answer over here, 3.75 grams of NaCl. Okay, so I bet some of you are questioning what happens with units here. Like, we had milliliters over here on one side and now we end up with an answer in grams. How does that all work out? Because the percent is a weight per volume percent, it actually is a grams per milliliter percent. Okay, but we don't like to write all of that every single time. So over here, if I erase, and let me try to give myself some more room. In fact, you could even write it in up here. If I wrote in grams per milliliter percent, which technically you could because that's what the percent is representing. And then when I do my math, it was 0.015 gram per ml percent. Now when I cross multiply by 250 milliliters, you would see that the milliliters cancel out and you are left with grams only, which is how over here we get an answer in grams only. But you do not need to write in grams and milliliter percent, okay? You do not need to write it. You just, if you're getting an answer for your percent, you just write percent. But when you work backwards, whatever you're solving for, you should have those units, okay? All right, moving on. This is the last question we'll work with this weight volume percent equation. And it says you need 45 grams of sodium benzoate, which is a food preservative. How many milliliters of solvent do you need to make a 0.75 weight volume percent solution of sodium benzoate? Okay, so now we are given grams, we're given the percent. What we don't have is milliliters. So we're solving for the denominator this time. the volume of solution. So what I'm going to do is, because milliliters is on the bottom, I don't like to solve for things that are in the bottom of an equation, the denominator. I am actually going to rearrange this equation first, I think, is what I want to do. So if we rearrange our equation, here we have weight per volume percent equals grams of solute per milliliters of solution times 100. So what I'm going to do is I am going to cross multiply by milliliters of solution on both sides. Okay, so what you'd be left with if we rewrite the equation down here, milliliters of solution times your weight per volume percent equals grams of solute times 100. Okay, so I just took this term right here, cross multiplied it, and moved it to the other side of the equation. Okay, so I should have written it on the other side as well, I just didn't have enough room. Now I'm going to divide both sides of the equation by weight per volume percent. Okay, so it'll go away over here, it'll cancel out. And now the equation we have is milliliters of solution equals grams, grams of solute divided by weight volume percent times 100. Okay, so this is the equation we want to use. So now let's bring that over here in the space we have left. So milliliters equals, we have 45 grams of sodium benzoate divided by 0.75%, plug everything in just as is, times 100. So now 45 divided by 0.75 times 100, you should get 6,000 milliliters. Okay, so 6,000 milliliters of solution. Okay, or solvent. 6,000 milliliters of solvent is what the question is asking for. So that is 6 liters. That's a lot. But you have a lot of sodium benzoate you're trying to dissolve to make a very small percentage or concentration, a very low concentration of solution. So 6,000 milliliters or 6 liters is our answer. Okay, this is the last practice problem. We are going to work on this video recording. Geez, I don't even know how long it is by now, but it is. We've been recording for a while, so after this we have a well-deserved break. All right, molarity, which is moles of solute per liters of solution. So it says I dissolve 2.335 grams of hydrogen sulfate, or that is also sulfuric acid, in H2O in water, and I dilute to 50 milliliters. What is the molarity? Okay, so we have some converting we have to do first, because we're given an amount of solute in grams, and to use this equation we need it to be in moles, and we're given a volume in milliliters, and to use this equation we need liters. So the first thing we're going to do is convert grams solute to moles. Okay, so to do that we are going to need the molar mass of H2SO4, and I'm just gonna look it up really quick. Molar mass of H2SO4, and it is 98.079 grams per mole. So I'm going to use that molar mass, start with the number given, 2.335 grams of H2SO4. And we will convert 98 0.079 grams in 1 mole. And when you do that math, you get 2.335 divided by 98.079, 0.024 moles. Number 2, we're going to take 50 milliliters, convert to liters. There's 1,000 milliliters, 1 liter. So you get 0.05 liters. Lastly, molarity equals 0.024 moles over 0.05 liters. And your molarity is 0.4, if you round, 48 molar. Okay, use a capital M to indicate concentration of molarity. All right, guys, we're going to pause here. Thanks for following and watching. Please, as you watch these videos, take notes, write questions, things that you didn't understand very well. And when we do our Google